First of all, I welcome you all to this video. So in this video, I'm going to explain how to use IAR, embedded workbench for lab experiment. So in order to do the demo process, I'm going to take LED flash experiments. So without further delay, let's get started. So first, let me explain how to open the IAR workbench in the system. So this is my main interface. In this, you have two options. The first one is in case if you have the icon, IAR icon, you can directly double click on it. You have to open that file. Or otherwise, here we have the search option. In that, you have to click IAR. You will get the icon like this. So you just double click on it. Once you have done this process, you will get the main window like this. So this is our IAR main interface. So in that first we need to create a project folder. So for that, in order to create the project folder, first we have to click the project. Here we have the create new project. You have to, once you have done that, you will get the new pop-up like this. So in that, there is tool chain. It must be in the arm condition. No need to change that position and give OK. Then it will bring us into the new window. So that is, we call it as the saving folder. So here we need to save our project folder. So for that, I'm going to give the name for that project folder. The name is ARM LED flash. So so here, whatever the name you have to give, it is up to you. I'm just giving the experiment name as project name. So then you have to click save. Your now, once you have done this process, the project folder has been created in the left corner. Then we will move on to that next step. The next step, we need to create a new file. For that, in that label, we have the file option. You have to click on the file. You will get the new option. Again, in that new, you have to create the new file. So after completing that step, you will get the new window like this. So in this window, it is especially it is used for to write the program code. You can write the program, or in case your code is in the document format, you can directly copy and paste it here. Here I have the program code as a document format, so that is why I just open that program document and I just copy all the content and I just paste it here. So next we need to save this file. So for that, here we have the option, saving option. You just click on it, you will get the new window like this. So in that you have to give the name for that file. So again, I'm going to give the same name as the file name. So ARM LED flash. Then the next step, it is very important. Here we need to give the extension file command. So for that, here I'm typing .s. The .s is the extension written file of this project folder. So you have to click save. Once you have done this process, our file successfully, it has been created in the project folder. Now we need to add this file into our project folder. So in order to do that process, you have to click project, and here we have the add file. So you just click on it, you will get the new window like this. Here we have to select our file name. So our file name is OM LED flash. I just click on it and give open. Now the project file has been successfully moving into that project folder. Now the next step is we need to give the project pathway. For that, you have to click the project and give option. So once you have click on it, you will get the new window like this. So in this window, the first we need to focus the general option. In the general option, the code should be in the ARM7 TDMI label. Then we have to enable the device. So here we need to give the device name. Our device name is NXP LPC2148. So you have to click this icon. You will get the interface like this. Here our device name is NXP LPC2148. So So this is the way to get that pathway. So once you have done this, again you need to enable the core icon. Then we move on to that next process, output converter. So in that output converter, we need to enable the generate additional output. So once you have done this, you will get the icons like this. In that output format, we need to change that portion Motorola into Intel extended port. Then output file, you have to enable the override default. Then we will move on to the next part. Then the next part is linker. This linker, it is very important. So first we need to enable the override default. So here we need to provide the linker path file. So for that, here we have the browse option. You just double click on it. You will get the option like this. So in that, first we need to choose our linker path. So for that, I'm going to click this PC. So in that this PC, we have the local disk. See, so you have to click on it and you have to choose program files x86. So in that you have to click IAR system and that embedded workbench on then examples. So our device name is NXP, so that is why I'm going to give NXP. So in that NXP, our kit name is LPC2148. So here we have the option LPC214X. You have to double click on it, and in that future micro block, you have to give that. Then time internal, then configuration, then finally we are achieved our flash link. So this is our class link. You just click on it. You are properly done the overall process. Then you have to give OK. Once you have done this process, our experiment, the setup process is thoroughly completed. Next, we are going to run our program. So in order to run the program, first you have to click the project. Here we have the rebuild all. So you just click on it. You will get the new interface like this. Here we need to save our file. So I'm going to give the file name as our the previous file on LED flash. No need to give any extension for this, and you just simply save this folder. So finally, in the down part, you will get the run command windows. So here you can observe how many errors and how many warnings in that. But our program it's accurately correct, so that is why we are not having any errors and warnings in this program. In case if you have any errors or warnings, you have to rewrite or recheck your program properly. So once you have done this process, next we are move on to the next step. So for this step, we are going to use another software which is called as Flash Magic. So here we have the icon. So I just double click on it. Once I have done this process, I will get the new window like this. So this is the Flash Magic interface. So in this Flash Magic interface, we have several steps. First, we are going to focus on the step one communication part. So in that step one, we need to focus on the communication part. This is very important because it is automatically fetch our system port. But before that, we need to ensure whether the port is in the communication tree or not in our system. So for that, we need to open our system device manager. So I'm going to open our system manager. So for that, I'm going to use my computer and in that, I'm clicking on the properties. Here, we will get the device manager. So in this device manager, we need to check our port, whether it is in present in the communication port 3 or not. So here you have a port option. You have to click on it. You will get the serial port name is COM3, communication port 3. So I have already told you. So it is automatically fetch our communication port. So first you need to verify our system port and the plasmatic ports both are same. So here the both names are same. So that is why we are moving on to that next step. The baud rate will be 9600 and device LPC2148 and the interface is none and oscillator frequency should be 16 megahertz. So you have to mention this kind of option in the step one and we are moving on to the step two. So here we need to enable uh, actually initially, there is no enable option present in that step two. We need to enable the second option, which is called as arrays logs used by hexafile. You need to enable this one. Then step three hexafile. So the step three hexa file, it is very, very important. It is which is used to execute this program. So for that, we need to give the execution pathway. So for that, we need to browse our file. So in that browse option, if you are clicking, you will get this kind of new interface. So in that, you have to click PC. So in that PC, you have to click local disk C. In that local disk C, you have to click program files x86. So here you have a IAR system. You have to click on it and embedded workbench ARM. In that you have to click examples. So in that example, you have to click NXP. So in that NXP, okay, now we are move on to that step three hexa file. So in that hexa file, it is very, very important because which is used to execute our program. So for that, first we need to give the pathway. So for that, you need to click the browse file. So in that browse file, initially you will get this kind of interface. In the document part, you will get to this kind of interface. In that, you have to click debug option. So in the debug execution, so you will get your hexa file. Actually, I have already saved the file like ARM. So I just click on it. So open. In the fourth step, you no need to do anything. I think after that, we are coming into the last step. So before doing this last step, first we need to ensure our kit in a proper manner. So this is the experimental kit. So in this, first we need to check the power option. So we need to enable the power option. Then coming to the next switch. So for this switch, it should be in the program mode. So whether it is execution mode, first we need to change that. Then give reset. Next in the software, we have to give start. Now we will get the output. So thank you so much for watching this video.